Okay, we can begin. So here's the question. By investing in a particular product for 1 year, an investor hopes to make a profit of $100, $400, $500, or $1,000 with probabilities 0.4K, 2K, or 0.12, respectively as shown below. Okay. So to make a profit of $100, there's a probability of 40%. To make a probability of $1,000, there's a probability of 12%. Now here I want to find the probabilities for 400 and 500 kwacha. Okay, as I said, calculate the value of K. Okay, so basically remember probabilities, they always add up to 1. Okay, so you say summation of the probabilities equals 1. Okay, so you make an equation here. You say 0.4 plus K plus 2K plus 0.12 equals 1. So, like terms here, K plus 2K, that gives us 3K plus 0.12. So we take the zero point 0.4 and the 0, we can even first add 0.4 plus 0.12, that is 0.52. So we have 3K plus 0.52. So like terms together, so this 0.52, we take it over the equal sign. So we're going to have 3K equals 1 minus 0.52. One minus 0.52, that is 0.48. So to find the value of K, we divide both sides by 3. So 0.48 divided by 3, what do we get? That is 0.16. Colleagues, confirm, is it 0.16? Yes. So the probability of making $400, 16%, 0.16. The probability of making $500, 2 times 0.16, 0.32. Any questions? Yes, yes. This is basically saying the summation of the probabilities. Have you seen here Px equals x? These are the probabilities. Very easy, right, madam? These are the questions you start with. When you see in the exam, you see, moment you just see this table here, you just start answering. Maybe the next question is, so how many marks is this one? Yeah, it's 10. Other times you can find it at 5. Depends on how the professor is feeling that day. Yes. Any questions, colleagues? Remember, probabilities always add up to 1. That 1 equals 100%. Okay, there's never a probability of 101% or probability of 102%. And also with probabilities, you never get negative values. Okay, so whenever you're doing any topic dealing with probability and you get a negative or you get a 1 point something, just know you've gone wrong somewhere. Okay, part B, find the expected earnings of the profits. So basically, we just want to find what is the average profit for this product. Okay, colleagues? We're just asking ourselves, okay, what is the average profit? Okay, if I invest in this particular product, what would be my average basically? Okay, so okay, let me just take this to the board because yes, ask your question. I can hear you clearly, sir. Oh, okay, okay. Okay. Also, you're asking me to read out when I was adding up when I made the equation. Okay, it's zero point 0.4 plus k plus 2k plus 0.12 equals 1. Okay, like terms, yes. Maybe colleagues, can someone take a screenshot and just post it on the group so that those who are having network challenges, they will be able to see the table so that, because here the other calculations will be relying on the table. Okay, so can someone just take a screenshot so to help our colleagues who are not able to what do you call this? See the board. At least maybe they can be following. Can someone just take a screenshot to help out our colleagues? Thank you, Madam Sylvia. You should be voted as Unzadesa president. Okay, president of you will do a great you will do a great service. Let me have vote. Okay. So now here we're finding the average. Okay, colleagues? We're just basically finding the average. Okay. Whenever you hear expected, when you're dealing with probabilities and you hear the word expected, or you see it, just equate that to average. Okay. So this is the formula you have to write. EX equals summation. So this is now Greek. Here. Summation of X multiplied by probability. So I'll interpret this Greek here. So what this equation is telling us to do is each probability, we're going to multiply it with the profit. Okay. Remember X, as you can see, the profits are represented by X. Okay. So each profit, you're going to multiply it with its individual probability. That's what it's saying here. Maybe we can write this down here. Each profit multiply by its probability. Multiply, not x, but multiply by its probability. Okay, so basically we start for the $100 profit, the probability is 0.4. So we're going to say 100 multiplied by 0.4. As I'm putting this, someone should be calculating. Plus profit of 400 times probability is 0.6. 0.16, I mean. Plus 500 multiplied by its probability, 0.32. Plus 1000 multiplied by its probability, 0.12. So you can give me the overall answer. Okay, thank you, sir. Thank you, sir. $384. So if you invest in this product, the average profit you expect to make is $384. Okay. Any questions? Questions, queries? Multiplied by P. So dots also mean multiplication, okay? Multiplied by. Okay, we can move to the next part. Calculate the standard What, did someone say something? Okay, yeah. Just get a screenshot, okay? It will it, it will also be helpful, okay? So that you can copy later. Calculate the standard deviation of the profits. So, colleagues, remember standard deviation. Basically, what we're talking about is how spread out are our data points, okay? But now, in this context, here it means we're measuring risk, okay? The risk in terms of how spread out your profits are going to be. If the profits are going to be spread out, it means this investment is going to be risky, because if the profits are spread out, for example, if we use our average 384, okay, and then we say, okay, profits are spread out, it means you can make maybe a profit of 2,000, You can make a loss of maybe negative 1,000. You can make a profit of 100 or 50. It will be fluctuating. The profits will be fluctuating. But if the standard deviation is small, it means the profits will be close to each other. Okay, so when I mean close to each other, maybe it can be 384, 385, 386, 387, or maybe 370. Okay, the profits won't be far away from the mean. Okay, so the standard deviation is just telling us how far the profits are from the mean, and that's indicating how risky this can be. Okay, if the profits are far away from the mean, the high standard deviation, then this is a risky product. But if the profits are near the mean, then it means when you invest, this is something stable, so you don't expect great fluctuations. So to get your standard deviation, remember, first you get your variance, which is just basically standard deviation squared. So this is the formula for the variance. E x squared minus summation, no summation, E x squared. Okay, then this ex squared, what it breaks down into is summation of x squared multiplied by p x equals x. Now, colleagues, not to confuse you, remember here ex is the summation of x multiplied by the probability. So when you just attach a squared here, basically what you're just saying is you're just putting a squared here on the x. Okay, colleagues? Just remember, if ex is the summation of x times p x, then if you put a square on the x, just means in the formula put a squared here. Okay. Then this ex squared, remember this is, where's the profit? This profit here. Okay, it's ex. So when you say ex squared, it means we're going to square this profit. All right. So this, before I go further, any questions? So basically what's happening here, colleagues, since we're squaring x, it means it's just like the same process we did earlier on here. The only difference is these x values here are going to be squared. Okay. So we start with the profit for 100. So you say 100 squared multiplied by 0.4. Okay, we're just squaring each profit, then we multiply it by its probability, plus 400 squared multiplied by the probability 0.16. plus 500 squared multiplied by 0.32 plus 1000 squared times 0.12. Okay, all of this minus, where is our average profit? 384 squared. So you can do our calculations. 100 squared times 0.4, what do we get? Or maybe, yeah, let's do it step by step. 100 squared multiplied by 0.4 plus 400 squared times 0.16 plus 500 squared times 0.32 plus 1000 squared times 0.12 okay, minus 384 squared Okay, so 4,000 plus 25,600 plus 80,000 plus 120,000. Minus 147,576 456. So that's just the variance. The standard deviation is just the square root of the variance. Okay. Standard deviations is just the square root of the variance. So 82,000, what's the square root of 82,144? Two 286.6. Okay. So now let me explain to you intuitively what this means. Because as I said, a greater standard deviation means greater fluctuations. Greater fluctuations, more risk. Okay. So we're going to compare this standard deviation of 286.6 to, for example, a standard deviation of 1 so that we see this. Okay. We said our average profit that we can make is $385, $384. So if it had a standard deviation of 1, it means you can make $383, you can make $385, you can make $386, $380, $382. Okay. As you can see, the profits they are not spread that much from the average. Okay, they're not that spread. Okay, so there are not a lot of fluctuations. So basically, it's not risk. Now, with a standard deviation of 384, okay, we start with the average here 384. Okay, you can make profit of, let's say, 280 minus 384. You make a profit of 100. You can make a profit of 500. You can make a profit of 50. You can make a profit of 600. So with a higher standard deviation, it means the average profits can fluctuate. They can be higher or they can be lower. So meaning it's more risk. So colleagues, if you are told you're given two investment options, one with a low standard deviation and one with a high standard deviation, like in this case here. If this was Project one, and this is project two. Which one would you invest in? Project one, because it seems more stable, right? It seems more stable. Okay. The profits are not fluctuating that much. Okay. Because most of us were conservative with our money. Okay. Whenever you invest into anything, you don't want to invest in something that which fluctuates greatly. Okay. Because you we are more, well, by nature we're conservative. Okay. We're not risk takers. But if you're a risk taker, you're going to invest in project two. Because there's a probability of making high profits, but there's a probability of making also lower profit, meaning you might start entering losses. Okay, so it depends on your risk tolerance. If you're a risky person, it's like a gamble. Okay, it's like bowler bet, colleagues. It's almost like bowler bet. Okay, when you're playing bowler bet, if you bet a five kwacha, it won't really pain you. Okay, because if you win, you won't win a lot of money. Okay. And if you lose, you just lose that five quatch. Now, someone who bets a 1 million, you can imagine the winnings are going to be very big, but also the losses also are going to also be very big. So the next part of this question says, hence or otherwise, is the investment likely to be successful? And explain. So the investment is likely to be successful because at least we've got an average profit of $384. Okay. So if you invest your money, on average, you make $384, which is compared to these profits between 100 and 1,000, which is reasonably fair. The only problem comes in that this investment is risky because we have a high standard deviation. Okay, and so it means this is the profits can fluctuate very far from $384. Okay, that's what the standard deviation says. So the profits can fluctuate way greater than $384. Okay, so it's likely to be successful because we've got a positive average profit. But since the standard deviation is high, it will be dependent on your risk tolerance. If you want high fluctuating profits, you can invest. If you want low, do not invest. If you're conservative, do not invest because the profits are going to fluctuate. So in a nutshell, it's likely to be successful. But it's an investment for people